NEC Section 409.2 A2 states that conductors of different systems, circuits, or classes of voltage shall not be placed in the same raceway, enclosure, or cabinet unless specifically permitted otherwise in this code. NEC Section 409.2 C2 addresses situations where conductors of different classes of voltage or circuits are installed in both raceways and cables within the same enclosure. It mandates the installation of raceway entrance fittings or ceiling fittings that maintain separation between the different classes of voltage or circuits. UL 508A, which pertains to industrial control panels, provides further guidelines. Section 36.8 of UL 508A requires that live parts of lower voltage circuits shall be separated from live parts of high voltage circuits by suitable barriers or isolation materials. Section 36.9 prohibits the installation of uninsulated conductors of different voltage classes in the same raceway or enclosure unless suitably isolated. To ensure proper circuit and component isolation, several practical measures can be implemented. Firstly, install physical barriers between high voltage and low voltage circuits. These barriers can take the form of metal partitions, insulating spacers, or appropriately rated terminal blocks. Secondly, utilize shielded cables or conduits to provide an additional layer of separation between high voltage and low voltage conductors. This helps to minimize the risk of electromagnetic interference and accidental contact. Thirdly, adhere to the minimum separation distances specified in NEC Table 310.16 or UL 508A. These tables provide guidance on the appropriate spacing required between conductors of different voltage levels. Fourthly, clearly label conductors and enclosures to indicate voltage levels and circuit function. This helps to prevent accidental contact and ensures that personnel are aware of the potential hazards. Fifthly, ensure that all electrical components are properly insulated and protected from potential short or ground faults. This includes using properly rated insulation materials and providing adequate overcurrent protection. Additional consideration should also be taken into account. The specific isolation requirements may vary depending on factors such as the voltage level, type of equipment, and specific application. Always refer to the manufacturer's instructions and consult with a qualified electrician for guidance on specific isolation measures. It is imperative to follow all applicable safety regulations and codes to ensure the proper and safer installation of electrical equipment. This includes adhering to the requirements of the NEC, UL standards, and any local electrical codes. Understanding voltage isolation is essential for electrical safety. It involves separating circuits with different voltage levels to prevent hazards such as electric shock, short circuits, and equipment damage. The NEC provides specific guidelines in Article 300.3, C1 and 300.3. C2 regarding the mixing of voltage levels in enclosures. When dealing with enclosures containing multiple voltage systems, physical barriers should be installed to separate high and low voltage circuits. These barriers prevent accidental contact and reduce the risk of insulation breakdown. Shielded cables and conduits are effective in minimizing electromagnetic interference and providing additional protection against accidental contact. The NEC provides guidelines on the proper use of shielded cables and conduits to ensure effective isolation. Proper labeling of conductors and enclosures is essential for identifying voltage levels and circuit functions. Clear labeling helps prevent accidental contact and ensures that personnel are aware of potential hazards. Select components with appropriate voltage and insulation ratings. This ensures that components can withstand the electrical stresses associated with the voltage levels in the enclosure. Consider directing components based on temperature and other environmental factors. Environmental conditions can affect the performance and lifespan of electrical components. Directing helps ensure the components operate within safe limits. Regularly inspect enclosures for signs of damage, corrosion, or loose connections. Address any issues promptly to maintain the integrity of the voltage isolation system. Proper grounding is essential for electrical safety. Grounding helps to minimize the risk of electric shock and provides a path for fault currents to flow. Provide adequate overcurrent protection for all circuits. Overcurrent protection devices, such as circuit breakers and fuses, protect against short circuits and overloads. Consider the use of surge protection devices to protect sensitive electronic equipment from voltage surges. Surge protection devices divert excess voltage away from protected equipment. Ensure that all personnel working on electrical equipment are properly trained and qualified. Training helps ensure that personnel understand the hazards associated with electrical work and how to perform tasks safely. When working on electrical equipment, always follow lockout/tagout procedures to de-energize circuits and prevent accidental energization. This helps prevent accidental contact with live conductors. Use appropriate personal protective equipment when working on electrical equipment. Personal protective equipment, such as gloves, eye protection, and arc flash suits, provides additional protection against electrical hazards. The use of appropriate tools and equipment for electrical work helps ensure that tasks are performed safely and effectively. This includes using insulated tools, voltage testers, and other specialized equipment. Voltage isolation is a critical aspect of electrical safety. Following the guidelines provided by the NEC, UL standards, and other resources helps to ensure that electrical equipment is installed and maintained safely. Isolation techniques are important for protecting low-voltage circuits from high-voltage interference. Physical separation involves maintaining a safe distance between high and low-voltage wiring. This can be achieved by routing the wiring through separate conduits or using barriers within enclosures. Shielding involves using conductive materials to enclose low-voltage wiring and block electromagnetic interference from high-voltage sources. Grounding is essential for providing a path for fault currents to flow safely to ground. This helps to prevent electrical shock and equipment damage. Filtering involves using electronic components to block unwanted frequencies and noise from entering low-voltage circuits. Surge suppression involves using devices that protect low-voltage circuits from voltage spikes and surges. Optical isolation involves using light to transmit signals between circuits, providing complete electrical isolation. Transformers can be used to step down high voltage to low voltage, providing isolation between the primary and secondary windings. Relays can be used to switch low-voltage circuits on and off, providing isolation between the control circuit and the load circuit. Proper wiring practices are essential for maintaining voltage isolation. This includes using the correct wire gauge, insulation, and connectors. Regular inspection and maintenance are important for ensuring that voltage isolation is maintained over time. This includes checking for damaged wiring, loose connections, and other potential problems. When working with high voltage and low voltage circuits, it is important to follow all safety precautions. This includes wearing appropriate personal protective equipment such as gloves and eye protection. In summary, voltage isolation is a critical aspect of electrical safety. By implementing the appropriate isolation techniques and following all safety precautions, it is possible to protect low voltage circuits from high voltage interference and prevent electrical hazards. The NEC addresses conductor ampacity in Article 310, which is crucial for safe installations. Table 310.16 provides ampacity ratings for conductors based on insulation type and ambient temperature. When conductors are installed in raceways or cables, the number of conductors and ambient temperature affect ampacity. Derating factors are applied when multiple current-carrying conductors are bundled together. Adjustments are made for ambient temperatures exceeding 30 degrees Celsius. The NEC also covers overcurrent protection in Article 240, which is essential for preventing overloads and short circuits. Circuit breakers and fuses are used to protect conductors and equipment from excessive current. The rating of the overcurrent device should not exceed the ampacity of the conductor it protects. Coordination of overcurrent devices is important to ensure selective tripping and minimize disruptions. Grounding and bonding are critical for electrical safety, as outlined in Article 250. Grounding provides a path for fault currents to flow safely to ground, reducing the risk of electric shock. Bonding ensures that all metal parts are electrically connected to create a low impedance ground fault current path. Equipment grounding conductors and grounding electrode conductors are essential components of the grounding system. The NEC also covers wiring methods in Chapter 3, which specifies acceptable wiring methods for different applications. Raceways, cables, and open wiring are common wiring methods. Each wiring method has specific requirements for installation and support. Proper selection and installation of wiring methods are crucial for safety and reliability.